Okay, Project F, Math 121. Again, starting Sage, whether you're doing the Jupyter Notebook or you're using it through the command line terminal. This is a project that I gave my students years ago. There's a polynomial, first degree polynomial. It says, you know, what I asked was on the curve, there's going to be two tangent lines, the 2 points on the curve that have a common tangent line. I'll be honest with you, for a lot of people, it's a difficult problem. Um, so what I would suggest is graphing it. So what I want to go through is just like if I were, I don't think I'd go to Sage to graph it. I just want to go to another application. And what I'm talking about is you really should have a tool chest available to you. And by the way, I'm not saying you can't do this by hand. Certainly in 119, you graph things like this by hand. But X4, I'm just using an application called Grapher, 2x squared. And then let's see, minus x, right? And I got this over here. And I'm going to just, kind of looking at it. I'm going to just change it a little tiny bit. And let me just, I don't know, maybe something like this over here. And I'm kind of looking at it. And it's not easy, by the way, looking at it. But I'm going to claim that if you thought about it, you could keep drawing tangent lines all over the place. But what you're trying to do is find 2 points in the curve that have a tangent line of the same slope, where those points out. Right. So I got a picture, but again, let me get rid of the grid too, and give me 1 second to do so. And let me just get rid of the grid, get rid of this. All right. Again, looking at that, if you look tangent line at -1, looks sort of like this, right? I mean, the tangent line over there, it's got the same slope as this tangent line over here, right? This one is, because, vertical tangents. Let's go back and read it. All right, let's see if it goes. I'm going to read that to you again. Years ago, I gave this to my students that have a common tangent line, all right? A tough question, isn't it? This is perhaps a difficult problem for most students. I would suggest graphing it, even if it's just doing a rough pre-calco sketch. The main reason for the graph is to visualize that a tangent line does exist that meets the requested condition. Take a ruler and try to find it. I think you'll discover at x equals -1 and x equals 1, where the graph of the equation line is x equals, you know what, let's put this in. Let's take a look at this. They say if I took a ruler to that graph, and I'm going to go back to my thing, and I'm going to put this down. See if I can understand what they're talking about. And this is the part of the, your study habits. And let's see. It says -x -1. Wow, this comes right at me, doesn't it? So I see the tangent line here. Wow, look at that. That's a miracle. Now, the question is, how am I going to do that? Well, they told me that. Right? That's nice to know. Now, let me read this over here. Take a ruler to find it. I think you'll discover that x equals -1 and x equals 1, where the tangent line, and again, you could print it out, probably take a ruler and do that. All right, not so bad. Okay, what I'm going to do now is I'm going to do it in a more abstract way. Because I'll be honest with you, if I didn't have a graphing utility, or if I really didn't quite understand what was going on there, I might have trouble with that. So I want to point out what I did over here was I wrote the function down, and then I said there's a is not equal to b, but there's two separate points. These are the x values, by the way. I plugged in f of a, I plugged in f of b. I did the derivative, and again, f prime a, f prime of b. I kind of wrote that down. It's really not bad to do, by the way. The problem being is, you solve that, and let's look at it. You get this over here, 4a cubed minus 4a minus 1. This is just me typing it up, by the way. I know for some students I read through this quickly, but the thing about it is it's not me reading to you. It's you thinking about this and working on your own. And that takes a lot of time and effort. Just like when I did the problem, it takes me effort too. It isn't like, oh, gee whiz, that's obvious. It's not. It's not obvious. But anyway, add 1 to both sides. Let's see, divide both sides by 4. I think I can handle that. Get the cubes on one side. Let me see what I got there. I guess you could factor that out. Yeah, it looks like I did that. Looks like I factor the cubic, and then I divided both sides by a minus b, and I got this down over here. Again, you're not seeing this stuff. I'm just talking through that. But when you work a problem, you see that stuff. If you don't work, you don't see anything. You don't see anything. All right? Your educations are void. All right? And then, over here, a little kind of nasty looking over here, but I guess I got to do something else, right? The slopes through the requested points should be equal to the slope of the tangent line. I put that down, right? That's an important thing, that f of a minus f of b over a minus b would be equal to this, right? That's the derivative evaluated at a. Went through a lot of work there, right? Boom, boom, boom. There's so much work there. It's incredible, right? All right. All that substitution in there, getting something. And yeah, it's tough, right? But then you boil it down to the end of it, and it takes time to work through that. Could be hours, could be days, could be a lifetime to work through that. I want to be honest, if you want to go into a STEM career, this should take like I'm going to say 30, 40 minutes maybe. And you might say it's not on time for that. Here's the weird thing is other people do have time for it. And that's what I call the privilege to study. And the people that have time to study, it is a privilege. They're going to do better in the long run, right? You may not have that time, by the way. Try to make the time. Try to make the time to study. But anyway, the point over here is I did it by hand. I got some points over here. And I got to be honest with you, it does get difficult. There's no doubt about it. I mean, it's tedious. So I want to get to this sage business over here. And I guess I should open it up, right? You know what? I don't have Sage running, so I got to open up Sage. But again, I want to point out, I got pictures over here, and again, I'm looking at it. It's getting to this end point, though, that, this thing over here might be tough. I'm going to open up my terminal. You know what? Let's open up by Sage, like this over here. I'll click on Sage. I'll open my terminal, launch it. Again, command line terminal. I'm not doing Jupyter. Let me scroll this up and reset. Oops. Don't be discouraged if this takes time. A, B, and X are variables. And we define variables before we use our variables. So variable A, variable B, and variable X. There's 3 variables in this problem over here. F of X. Again, if you can't remember what f of x, you can always look it up, but it was x4 minus 2x squared. That's 2 star x squared. And then minus x. Oops, I made a mistake somewhere. Let's take a look where I made a mistake. I see it right now. I used an underscore, and I have to get rid of that. And that was minus x, right? All right, did that. All right, let me go back up here and point out what I mean by this. I just typed in the function over here. All right, let's go back to our Sage. And Sage is nice to have as a tool. It's a really nice tool. And then, plotting it. Well, I've already plotted it, so I'm not going to do that again. But I'm gonna define a new function, df of x. Now, this is my way of naming a function by saying it's the derivative of f of x. And what is that going to be? The derivative, diff of f of x with respect to x. So I could display that df of x. By the way, that's not difficult. I could do the derivative. What's going to be 4x cubed minus 4x minus 1. You could do that. All right? And then, I get looking at this over here, you may wonder what I'm doing over here. I'm doing the slope of the tangent line on 2 points on the curve, and one is, f of a, f of b. And I'll put the slope down. So I'm gonna say f a. I'm just typing this in now for you. Minus f of b. You know what? I got it. Since it's a slope, I got to do f of a minus f of b divided by a minus b. All right. Now that's an expression over there. Now certainly someone says, I don't know what you just did over there. I'm going to explain it to you. So I want to go back to the picture that I had before. A and B are on the curve. A does not equal B. So all I did was, like let's say it's here, it's, this is f of A, I'm sorry, A, f of A. Over here, this would be B. So that would be b f of b. And I'm just doing a slope between those two. It's a slope of a secant line. That's all it is. All right. So, I did that. And the question is, why would you have done that? Well, I see it over here, but I hope you know what that is. Now, I notice I use this command full simplify. So I'm going to use underscore dot full simplify. All right. I'm sorry. Maybe I made a mistake there. Simplify. Full. F-U-L-L. All right. Let's see what it looks like. Wow, it simplified it. Not by a lot, by the way, but it did simplify it. All right. Now, I could certainly use that again, but what I'm going to do is I'm going to, a little bit different than they did. I'm going to say equation 1 is going to be equal to the prior output, and that is going to now equal to the df, let me put this down for you, df of A. All right, let me hit return. All right, now I could display equation 1, EQ1, and that's what EQ1 looks like. Now what I want to do is I want to solve SOLVE. Yes, the code is different. Why is that? You're going to learn by working. And I'm going to solve equation 1 for B. And I got it right over here. Now granted, you might look at that and say, gee, I don't know what that means. But I'm, kind of reading it. Same thing I got up over here. By the way, if people are curious about my notes, by the way, my notes are being typeset in LaTeX. And I'm also using Sage within my notes so that the output's being generated automatically in my notes. All right, so I'm getting this, the minus a minus square root of, blah, blah, blah. I'm getting the b is equals over here. So there's two values of b, all right? Let me keep scrolling along. It's tough, but it's doing all the work for me. And it all goes down and says b equals a, all right? Now, I want to solve that same equation, by the way, not for b, but for a. And what am I getting over here? I want to put I'm getting the same output. At least I think I am. Give me 1 second over here. Oh, I'm sorry. I misspoke. I misspoke over there. Let me talk about what I'm doing over here. Again, I want to point out what we got over here. We got this equal to that, and I want to point out what we're looking at over here. So really what I'm doing is I'm taking this, and I'm saying it equal to this over here. All right? I'm going to put that in for you. Solve, S-O-L-V-E. And I'm going to, again, this is one of the b values. Whoops, sorry about that. I didn't mean to do that. Let me close that out. Let's see if I got that right. I don't think I copied it all. Equals. Whoops, way too much. What's the other guy going to be equal to? What's the other b right over here? And we're going to solve that for the letter A. And I get -1 and 1. Right over there, same thing. All right. What's the line? And this is what we did in the beginning, by the way. We did it by visual approach. And let me type that in for you. Y1. This is another equation, by the way. I'm assigning it df evaluated at, let's see, -1. And then, let's see, times x plus 1. Again, I'm just putting the equation line down. This is, pretty simple to do, something you learn in Math 100. Equation of the line plus f of -1. Let's just display that. And what do you get? Well, it's -x minus 1, which is what we're expecting to see. All right, we're expecting to see that. If we did the other one, for example, at 1, we're going to get the same thing. And then all I did was I plotted it. I want to claim, though, when I do this, this over here is a graph of it. And let me see if I plot both of those down there. And yeah, doing this over here. We did that at the very beginning, if you recall. Okay, so let me point out, this is not an easy question for students, all right? Now, again, visually, you might say, well, I think I could do it, but I need more explanation to understand what the question was, and it happens sometimes. A lot of times questions can be very difficult because you don't understand what they're asking you to do. But I got to be honest with you, the algebra was pretty tough in the question. And that's where, formulating something and realizing you're coming into some really difficult work, that you may say to yourself, I really do need some assistance. I need a tool. I need something to help me carry that heavy weight. And you can start using tools, right? I want to point out to you, the use of tools is going to be important for you. Your ability to realize you need a tool and you need to go to your tool chest. What tools did I use today? Sage, and I also use Grapher, right? Let me just point that out to you. I use Sage, that's my terminal version of it, and I use the application Grapher, all right? So I think we're pretty much done with that. But again, when I say we're done with that, that really requires you to put some time and effort into thinking about what's presented to you. Thank you so much for paying attention, though.